Hello and welcome everyone to session 1 of our new webinar series, Stepping Through an In-Building Project Lifecycle, co-presented by iBwave and PCTEL. In this webinar, you will learn through concrete examples and live demos about the best practices and cost-saving techniques for efficient project management during each step of an in-building project. To start, I would like to introduce our speakers today. From iBwave, we have Alex Jovel. Alex is the Manager, Sales Engineering at iBwave. Alex has over 15 years of experience as an RF engineer based in Los Angeles. He currently oversees all sales engineering efforts for the United States, Canada, and Latin America, which includes managing professional services, business development, and solution deployments. Alex holds a bachelor's degree in electrical engineering from Northwestern University. Also from iBwave, we have Nazim Chaudhry, who's our sales engineer. Nazim is responsible for supporting sales engineering projects in the US. Nazim works with customers and potential customers to ensure they have a firm grasp of iBwave product suite. Nazim holds a bachelor's degree with a specialization in engineering and computer science from Concordia University. From PCTEL, we have Scott Clay. Scott is the Senior Director of Engineering Services. He has over 19 years of progressive experience in the design, commissioning, optimization, and management of RF engineering services at companies including PCTEL and Vision Wireless, where Scott was a co-founder, Agilent Technologies, and Safco Technologies. Scott holds a bachelor's degree in electrical engineering technology from University of Central Florida. Also from PCTEL, we have James Zake. James is the Vice President of Product Management. He has more than 20 years of industry experience leading key engineering projects. James holds a BSc and MSc in engineering from University of Wisconsin-Madison. In just a few short minutes, we will start our presentation, but before we begin, I would like to go over just a few housekeeping items. First of all, thank you for all the questions you sent while registering for the webinar. If you have any additional questions during the webinar, please put them in the question box of the GoToWebinar control panel, and we will answer as many as we can during the last 10 minutes of the session. We will respond to the remaining ones after the webinar via email. For those who may have audio difficulties, we will try to speak as loudly and clearly as possible, but please make sure to check your audio settings on your computer or phone as you dial. We will be recording today's webinar and sending the recording over along with the slide deck of the presentation within the next few days. The recording will also be available on our website in the next few days. Also, for the part 2 of this webinar, we will be holding that webinar on November 11th, so please look forward to the invitations and remember to register for the part 2. Now, without further ado, I will pass it over to our presenters to start over today's presentation. Thank you.
Thank you, Amna, and thank you everybody for joining today's presentation, and thank you PCTEL for participating with us today. So today what we're going to do real quickly, we're going to do a quick overview of companies that are going to be participating today. And then during the workshop, like we mentioned earlier, it's going to be a 2-part series, and today's first part, we're going to cover the network planning and dimensioning and also the detailed engineering. And at the end, we'll have some closing remarks along with a Q&A session. So before moving on, I'll go ahead and hand this over to James so he could do an introduction into PCTEL.
Okay, thank you, Alex. PCTEL is a solutions company which delivers performance-critical telecom solutions for both public and private wireless networks. We consist of 2 divisions. One is our Connected Solutions, which designs and delivers performance-critical antennas and site solutions for wireless networks globally. And then there's the RF Solutions division, where Scott and I are from. We provide test equipment, software, engineering services, and network analytics for wireless networks. On the network engineering services side, we really specialize in expert knowledge and exceptional tools. And we're really focused on in-building distributed antenna systems and small cells. We really do, for services, the whole product lifecycle, and this includes network benchmarking, baseline testing, the CW testing, design, commissioning, optimization, acceptance testing, PIM sweep and fiber testing, interference mitigation, and consulting. So it's the whole product life cycle for an in-building system except for installation. On the product side, we manufacture scanners for development, testing, and optimization, and these include our flex scanners, our iBflex, EXflex, MXflex, which are used for walk and drive testing. They're really very programmable scanners that can do any type of cellular band, programmable in the field, as well as the software that collects the data from the scanners, our Seahawk software and our Seahawk Touch software, which is our Android-based software. And in addition to that, we have a CW transmitter for putting out transmitting CW signals for in-building, as well as interference hunting with our C-Wave product, which uses the scanners as a method of collecting the data for finding this interference. So back to you, Alex.
Thank you, Jim. And really quick overview into iBwave. iBwave is a software solutions company for planning, design, dimensioning, operating, and documenting of wireless and building networks. We have solutions that are running on PCs, servers, and mobile devices such as smartphones or tablets. And our solutions are mainly used by wireless operators, equipment suppliers, as well as system integrators in over 80 countries in the world. And if you look at our portfolio of solutions, if we start here on the left-hand side, we have our flagship product, iBwave Design. This product comes with 3 optional modules for propagation, optimization, and collection. And then this is the tool that's also standardized by Tier 1 operators all over the world. And after that, based on market needs, we saw that there was a need for the management and control of in-building projects and getting analytics. So we have Unity for that, and it serves for project control, data mining, amongst other things. And this one also comes with 2 additional modules for project management, and you have a module for API to connect to other internal systems from a company. On third here we have iBwave Mobile, and this is an Android-based solution for smartphone and tablets. And we have 2 versions of mobile. One is called Note, and Note, what it does is basically allows you to save time by the ability to digitize a site survey. And we also have the ability to collect data collection with RF platforms such as PCTEL, ASCOM. Today we're going to be focusing on PCTEL, and then you could also take it a step further with a different version of mobile that's called Planner. And what this one does, it allows you to go ahead and run predictions for small cell and Wi-Fi, and you have the opportunity to use your data collection for the predictions on a tablet on the field. We also have our certification program. Our certification program, there's 3 levels for our ICP, and it's focused around design. And each level, if you were to take it in class, would take 3 days each. And we have 3 different formats in which this is delivered. We have our in-class, so we have a schedule of where we're going to be visiting the cities worldwide and the different classes. We also have our virtual classes where you have a dedicated resource online. And then you also have the option of doing it online at your own pace, where you give a student 30 days to finish each level. And finally, we have our database of components. On here, you could pretty much, it's the largest database for in-building components. You could go in there, download the parts you want, and for example, do a comparison between the performance of different antennas, let's say, inside of a DAS, or performance of different small cells. So that kind of covers a little bit of our portfolio. And then in today's presentation, what we're going to do, like I said, is we're going to go ahead and cover a life cycle of an in-building project and see where the different products fall into place. So initially, when we talk about a life cycle of an in-building project, the first step is getting some kind of a floor plan where we have to do some kind of a dimensioning. Ideally, we have a design that you could do that, or we have a separate solution just dedicated for drawing that's called 3D Modeler. You could use that for dimensioning, and then you have to do some kind of planning, right? And this is where you kind of have to do some kind of a walk test, either to get a baseline of the macro signal that's already in there, and if you could at the same time collect CW data, then perfect, right? So we do that. We could use iBwave mobile note and the integration with a tool like PCTEL. After that, we have our design where we could get, have a calibrated model, go ahead and run the necessary predictions to get our ideal solution to achieve our KPIs. After that, we hand it to somebody that's going to pull the actual wire, do installation of antennas, and obviously we have to make sure that everything's connected correctly, you're reaching our criteria, so you're going to have some kind of commissioning. And afterwards, you want to verify that this is all working. You'll have your as-built documentation. And finally, this is handed over to some kind of a field ops team, right? And they're the ones that are going to go in there maybe and replace parts that are broken. So we're going to cover this whole life cycle today. Like I mentioned, it's going to be the first two sections. And what we did is we actually took a real case study from the PCTEL office in Melbourne, Florida. So Nazim had the opportunity to go in out there, and it's your typical small office, criteria. We captured floor height, approximately how many users were going to be in the venue, along with the composition of the different walls. So if we get started on the first step and some of the benefits, real quick here, we have a slide that covers a little bit more in detail as to what we're going to be covering in today's presentation. So PCTEL will do an excellent job covering topics such as spectrum clearing and CW testing, and we'll highlight some of the stuff that you could do with a site survey. And this is kind of like the first step, right? So initially, like I said, if you have something that you could do a preliminary design, or at least draw and design or 3D modeler, great. If not, you can go into the field and capture information for the floor plan. And really, when you're doing that first trip, right, what we're trying to do here is we're replacing that engineer going out there with floor plans and a digital camera. The typical process meant writing notes on paper, taking these pictures, going back to your hotel room or office and spending another 4 or 5 hours to organize this data. So why not capture everything in one spot and save ourselves a little bit of time there? And really what we're capturing is where we're going to put head-end equipment, the different risers, maybe pictures of the environment, validate materials are going to be some of the things that we want to capture in the first visit. Like I said, we also integrate with different RF data collections, so this is also very important, and it allows us to collaborate, right, between the field and office teams using the cloud, and this, has a tendency of speeding up and streamlining our processes. In the case of the PCTEL office, we didn't have a preliminary design, so we actually went out to the field, we took a picture of the fire escape route, and then started doing our capturing our information for our project there. We captured vital information as far as like the address of the location, how many users exactly you have, the type of requirements, and then like I said, we have these what we call annotations in iBwave, these little push pins here, and with each push pin you could associate different type of video, audio, text, things that you would use to capture information as far as where you're going to put antennas, where you're going to put your hand-in equipment. And like I said, there's a big benefit of being able to collaborate with tools such as PCTEL, where you could go ahead and capture your walk tests as far as like pre-install, so you could see where you might have coverage gaps already coming in from the macro. And the benefits of using something like PCTEL, well, they also have scanner where you could go ahead and collect CW test data. So based on that, let me go ahead and pass over the control over to Scott so he could talk a little bit more about the importance of the data gathering and show this integration with PCTEL.
Thank you, Alex. So what I'd like to do is go over the best practices, strategies, and cautions of the 3 types of tests that will be performed during the planning and dimensioning phase of the process. First would be spectrum clearing. Spectrum clearing is done for both DAS and small cell deployments. Baseline survey as well is done for both DAS and small cell deployments. And then finally, pre-deployment CW testing, which will also be done for both deployments as well. We'll start with spectrum clearing, and the purpose of spectrum clearing is to determine that the channels being deployed are clear from interference. With new bands being deployed and old bands being used for new technologies, it's really important that spectrum clearing is performed and performed accurately. It is also used to provide clear frequencies for the CW testing that will be done during the pre-deployment CW testing. And that's very important as well to make sure that those frequencies are clear of interferers so that they can provide an accurate input into the design tool. Next is the baseline survey. And the purpose of the baseline survey is to identify what the current coverage from the macro site is in the building or the venue that you're going to be designing. We look for gaps in coverage and use this to determine coverage objectives for the system. It's also used to identify which wireless service providers are in the building, especially for neutral host deployments. We can decode PCIs, scrambling codes, PNs, and BSICs. That requires engineering tools with blind scan that allow us to go out and sniff the RF that's in the air and determine exactly which frequencies and technologies are deployed in that building. We also identify if there's any existing repeaters or DAS that are turned on in the building. It's important to know that so that we can collect data accurately. We want to make sure that if there is a DAS turned on in the building and we don't have the ability to turn it off, that we have a scanner with high dynamic range so that we can still decode the macro signals within the building that may be overcome by the DAS. We want to identify signals on multiple floors and ingress and egress points. And this is used to create a baseline for the DAS and small cell design. It's a very important information gathering stage. We utilize it to accurately map the current RF landscape for deep analysis, which requires, as I mentioned, tools with high data density and dynamic range. It allows us to determine what is necessary to achieve in-building signal dominance. It also identifies which macro cells may be problematic to the DAS or the small cells that are being deployed. We identify potential neighborless candidates from macros to DAS or macros to gateway APs. We identify the ingress and egress for potential handoffs into the DAS from the macro and out of the DAS or small cell to the macros themselves. And this baseline survey is an input into the design tool so that you can run predictions and determine whether or not you are achieving that signal dominance. Some cautions of the baseline survey: you want to make sure that you have accurate timing for CDMA and EVDO. You want to have a scanner that has sufficient holdover so that you can have that holdover throughout the entire duration of the test being performed. If you don't have that holdover and you lose timing, the data collected for CDMA and EVDO will be inaccurate. All target areas must be tested. It's important that you understand what the objectives of the design are prior to doing a baseline survey so that all those areas are tested. Using UEs or scanners with low dynamic range could provide a lost opportunity for optimization. You want to be able to decode those macros no matter where you are in that building so you can see which macros are going to be problematic, whether they can be utilized for handoff candidates and ingress and egress points, or if they need to be optimized to get them out of the venue so that the DAS can achieve dominance. And wireless service providers' channels are improperly identified. You certainly don't want to miscollect data and have data collected for carrier A when you're designing for carrier B. That would not allow you to achieve the signal dominance necessary in those buildings. Some additional considerations are really open-air stadiums. They pose a unique challenge because they are open air, and a lot of times the macro networks are designed to cover these stadiums. They even put macro cells on top of a lot of stadiums. This makes it very difficult, if not impossible, to achieve DAS dominance in a venue of this type. So it's important that you understand what the macro coverage is so that those macro cells can either be optimized by reducing powers or adjusting tilts and azimuths, Or maybe the option is to turn that macro off, which is in rare cases, but a lot of times we turn macros off during events so that the DAS can achieve its dominance in there and offload the entire macro system for capacity reasons. For pre-deployment CW testing, the purpose is to determine the RF propagation characteristics of the venue. It provides a very important input to the design tools so that they can optimize the prediction models. And it can be used to validate preliminary designs so we can determine if anchor antenna locations are acceptable for the design. It can also be used to determine soft handoff locations and percentages by basically setting up two different transmit locations on different frequencies that are in adjacent sectors. You can determine whether or not those soft handoff regions are going to provide the appropriate targets so that the soft handoffs, your areas are not too large and are starting to eat up your throughputs. It's a direct input to the design itself for model optimization. You want to accurate report all intended coverage. Accurate scanning receivers with high data density is important so that you can make sure that you're getting enough data to tune that model. And you want to test all bands simultaneously because you want to make sure that as you turn up a CW test that all bands are accurately being modeled. You want to make sure you understand what the prediction, what the propagation is going to look like in a building and what the penetration losses of each frequency is going to look like through the different medias inside of the venues, whether it's through glass, drywall, wood, cement, floors, ceilings, all of that you want to accurately model and make sure that you collect enough CW data that the models can be tuned for that. You want to locate CW antennas in the same location where the DAS antennas or small cells are to be located so that you can basically validate that preliminary design and make sure that those locations are going to be good. You want to simulate soft handoffs, so by setting up two transmitters in adjacent sectors and making sure that you collect enough data there which would give them ideas of how to optimize those soft handoff regions, whether it's through azimuth changes or tilts or power. Some cautions. You want to make sure that your frequencies are clear at all times. External interference or macro cell infringement is not good. You want to make sure that you clear your frequency prior to testing and then verify that that frequency is still clear once you end the test for CW testing. It's very important to know that that frequency has been clear the entire time or it'll cause you to under or over predict in your model. Antennas placed inaccurately is a caution as well. You want to make sure that you place those antennas as accurately as possible based on the preliminary design so that if you are trying to optimize tilts or azimuths, you can take advantage of that. CW power levels not set to expected design is another caution. You want to make sure that you set the power levels correctly, and if not, you may want to basically set the powers a little bit higher than what you would expect so that you can collect enough data in the building so that the design engineer can back those power down and make sure that they have enough data to optimize and tune that model. The most important phase of all for pre-deployment CW testing is accurately documenting what your setup is, antenna heights, azimuths, tilts, powers, all of that information and frequencies is very important to give to the design engineer so that they know what the exact setup is and they can mimic that in the design tool itself so that when they do their propagation model optimization, it is done accurately. Some additional considerations, as I mentioned, make sure that that frequency is clear and that you verify that that frequency has remained clear. We've had some examples in stadiums where we've cleared a frequency for one area and then the next day we go out to another area of the stadium and that frequency is being used. So it's very important that you clear not only on a daily basis but as before and after each CW test that's being performed. I'll now hand this off to Jim Zick so that he can do an interactive demo.
Okay, thank you, Scott. So what I'm going to do here briefly is I have a pre-recorded demo of how the iBwave mobile planner is actually integrated with our Seahawk Touch, which collects scanner data from our IBflex scanner. So first, we select iBwave Mobile Planner icon, which launches iBwave Mobile Planner, as you see right now. And I already have preloaded into iBwave several buildings. And what I'm going to select is actually the demo PCTEL building in Germantown, Maryland. So with this, we have several floors, and I'm going to select floor 3 is what we've done. And the layout for floor 3 is actually here, and I've already pre-scaled the 18 feet distance on this layout that you see here. So now I'm exporting this actually right to Seahawk Touch. With Seahawk Touch now, I have to be able to detect the device, the iBflex scanner, to be able to collect data from that scanner. So right now it's through a Bluetooth connection that I'm actually finding all the scanners out there that have Bluetooth. In this case, in our building, we have 3 of them. The one I'm using is a 7041 scanner. So with the scanner now, I have the data now imported from the floor plans imported from iBwave Mobile Planner. I'm selecting floor 3. In the interest of time, I have set up a predefined setup, which we call a workspace. That workspace is defined as the iBwave LTE Web. What it is the upper 700 CD band that is actually in this workspace. And I'm actually going to plot the RSRP, which is the reference signal resource power, instead of the RSRQ that default value came up. Once I apply this, because that's a very important parameter, I'm now going to actually do a walk test I've done previously and show that to you. So first what I'm going to do is select the starting point on this walk test, which I've done. I'm now going to record that, and I have the option here of changing the name of that file of where the data is loaded. And now I'm actually walking the venue. So as you can see, the RSRP points are actually plotted right on the layout of the PCTEL building. And I'm doing just a very brief walk test here for this demonstration. So now once I've completed this brief walk test, I'm stopping the scanner from taking the data and Seahawk Touch. And now what I'm doing is I'm reloading iBwave Mobile Planner right from our Seahawk Touch. I'm launching it, and I'm actually selecting which file I actually want to import into iBwave Mobile Planner. So I'm selecting the data I've just taken. I've imported it now, and as you can see now in iBwave Mobile Planner, I actually have the RSRP data plotted right on the plot, on our layout of the building. And now I'm doing the final export, and it's as simple as that as far as collecting scanner data from iBwave Mobile Planner. I'm going to pass it over to Nazim now.
Thank you, Jim. So really what I want to do now is revert back to the actual case study that we did. So we saw the importance of collecting good measurements while you're out in the field, getting good information while you're out in the field. So now I want to talk about that and relate it to that live case study that we did at the PCTEL Melbourne office. So right now, what I have here is my mobile note application. So I'm going to launch the application. And if you remember, Alex was mentioning before, it really depends on your process. Are you going to start your design first in the iBwave design tool, or are you going to start your design really that moment you get into the venue for the first time? So you have both options, and the great thing about these tools is that they integrate completely with each other. So at any point in time, if I start a project on my tablet, I could open it up directly in my design tool, and vice versa. If I start my project in my design tool, I could open it up directly on my tablet. And this really allows proper communication between the field technicians and the design engineers. So back to our actual case study. So for this example, I had nothing at all to start with. I just went to that venue and I want to try and gather as much relevant information as possible. So the first thing that I did was I wanted to have a good floor plan to work with. Now, if you have a floor plan already on your tablet, you could import it directly. But even if that's not available, what you can do is you could go to maybe an emergency evacuation plan, quickly snap a picture of it, and you'll have something to reference to. And that's exactly what I did for this example. So again, my first step was I want to bring in my floor plan, and I want to actually make sure that I had the appropriate dimensions for my, my floor plan as well. So here you can see I also have a well-scaled floor plan. So that was my first step. I wanted to have something to reference to, something to work with. Now, before starting my actual physical site survey, I wanted to get a good understanding of what kind of signals I'm already dealing with from the outdoor macro network. This is going to help me decide what kind of solution I'm going to need, and also it's going to help me visualize really what kind of interference, what kind of signal strength is already coming in from that outdoor network. So as Jim just showed us, we have the ability of integrating back to different collection tools, and in this case we use the PCTEL Seahawk platform. So just by clicking on this little button here, it will allow me to activate that collection tool, and it's going to allow me to bring in those measurements here directly. So that's exactly what I did. My first step, I want to bring in my survey information. And as you can see here, now I have my walk test available. So I brought in that information and already have a good understanding of the outdoor macro network. I could already see areas where it's a little hotter. I could see areas where it's a little colder. So I already have a good visual representation. And one of the great things of working with a collection platform such as PCTEL Seahawk is that you have the ability of doing multi-band, multi-frequency scanning. So I have the ability of pushing all those frequencies directly into my mobile node application, and I could toggle between these different measurements. If I want to go to, let's say, 1900 now, I could just simply toggle to 1900 and now visualize my 1900 walk. So you have the ability of toggling back and forth, and on this application here, right now I'm visualizing RSRP for LTE, but if I want to, I could also toggle over to RSSI. So I could toggle between the different metrics, and again, if it's a WCDMA or HSPA, we could toggle between RSCP. So that was my first step. I want to bring in good macro information. So now my next step would be to actually get good physical information about the venue, such as where I might want to place antennas, where my head-end room is, where I want to place my equipment, where I'm going to have risers. So I want to gather all that information. And already I could see here that maybe I might need to put some equipment here just to make sure that I'm going to be dominant in this area. So that was really my next step, to start getting physical information. So to gather physical information, we have the ability of using different push pins. Now, what each of these push pins represent is it allows us to highlight what's going on in a certain location. So let's say, for example, I saw that there's a conference room in this area, executive office. I know I'm going to need good coverage in those offices, and I also want to visualize what those offices look like, what those rooms look like. So I dropped a push pin, and that push pin allows me to document what exactly is going on in that location. And just an example, I have the ability of annotating it with a picture, a text message, a video message, even a voice message. And in this case, I used a picture, and I took an exact snapshot of the area. And even on this tool, I have the ability of taking notes on it directly. So from this picture, I want to highlight where the antenna is going to go, what the cable routing is going to look like as well. And oftentimes when we speak to field technicians, they usually mention they like jotting down notes, they like taking notes directly on floor plans. So we have that capability as well. We have a markup layer, if I could show you right here. And what this markup layer does is it also allows you to get different information about your venue and just quickly jot it down with your pen. And for me, what I used it for is I want to show where there's ingress-egress areas, where different material compositions, where I saw there was plaster, where I saw there was glass, and I even want to highlight potential cable routing locations that I saw at the venue. So this was my first step. I wanted my good baseline data, and I want to collect physical information about my venue. So again, as we spoke about before, another step in the process would be to get good CW measurements just so we could later on fine-tune and calibrate our propagation model. So I'm going to send it back to Alex so we could talk a little bit about the CW process.
Thank you, Nazim. So far we covered exactly that, right? The importance, folks from PCTEL covered how important it is to capture the appropriate CW test data. We showed the integration. There's other things that you could also do with mobile, where you could also put an annotation as far as where the transmitter is located at, and then document important information that we mentioned earlier, like height, azimuth, any tilt, model of antenna you're going to use to get this information to your RF engineer. We also have the ability to go ahead and taking a picture of a CW equipment and verifying that that is being used in the correct way. And we showed the integration, right, of with PCTEL to go ahead and collect the CW measurements, being able to visually see it back onto iBwave Mobile. And then now what this also iBwave Mobile allows you to do is now you could go directly to design. So in the past, what you had to do is you had to use some kind of a tool like PCTEL, collect CW test data, export it, post-process it, and then have it in some kind of a generic format to import it back into iBwave per band. So now there's a big time that's being saved where you go directly from mobile note, do that integration with PCTEL, and send it directly to design. So you have the ability of streamlining that process. Once you have it in design, well, now you have the ability of loading this CW test data into our environment, and we could do various things as far as being able, validating, that our walls are modeled correctly with appropriate losses, or we could go ahead and use this information to calibrate our model along with the materials, or either or, depending on what we want. Because inside of iBwave design, what we have is we have an engine where you could go ahead and create different kinds of calibrated models. You also have the ability to document it. The thought here is so you could go ahead and use it for future designs. And then we also have a couple reports that are available that you could use pre the calibration and post calibration to see how much you have improved in things like mean error, standard deviation, and absolute mean error. So this, having calibrated models is going to reassure us that we have the accuracy that's needed to go on to the next step for detailed engineering. So let me pass it real quick back to Nazim so he could go ahead and show a quick demo on how this is done in design and mobile.
Thank you, Alex. So I wanted to come back to my exact same file. So I want you to think of this file kind of as a container. So we collected all that information. All that information is still available and stored on my file. I could easily access it just from these different layer managements. So if I want to see my markups, I want to see my annotations, I could just turn them on again. So the next step was we had our baseline data. It's still stored and saved on this file. The next step would be to start looking at our CW data. So again, as Scott was mentioning before, a key factor when it comes to CW testing is you want to make sure that you have your components, really document where you placed your components, as well as the height of the component, the power of the component, and just really document that information, because your CW test is going to be really dependent on where you placed it, the power coming out of it, the height of the component. So we really want to document that. And that was the first step I took. I placed my CW transmitter, I placed the height, I placed the power coming out of it, just so I could properly document it. And then again with the PCTEL Seahawk integration, I was now able to bring in that CW data directly. So if I come back here, and I turn on my survey measurements, and this time my survey measurements is labeled as CW. So if I want to revert back to baseline or pre-install, I could revert back to it as well. But now you can see I could visualize my CW testing. And again, like before, we have the ability of seeing our CW test for all different frequencies that we've done the testing for, so we could toggle between them and really start visualizing it. So this was the next step. We want to get good CW measurements, and now on our floor plan we could visualize, already we could take a look at it closer to the transmitter. We're seeing strong signal, and we could see it fade along with the path loss. And this is also going to allow you to verify different materials that are in place. Let's say we had a metal wall here. We would have seen that the signal will degenerate in that area. So in these first two steps, really what I did was I collected and gathered as much information as possible that I could pass on to the designer so he could make a very well and thought out design. So if you just think about the traditional process, there's a lot of steps that you had to previously take. You had to take out your digital camera, take out all your photos, resize them, relabel them, reference them to your floor plan, then scan your floor plan, and then when it comes to survey measurements even, you have to go through another post-processing step, convert it into CSV, and then bring it into iBwave design. So there's a lot of time that was taken even after you leave the venue. So we want to really automate all those additional steps, and just by the simple click of this button, I could send all that information over to the designer directly. And that's what I want to come to now. So I'm going to come back to my design tool, and really what I did was I opened up that same file that was being worked on in the field in my design tool. So now if you look at it, as a designer, my job just got a lot easier because I have all my information laid out for me. I have my wall materials, I have potential antenna locations, and I have all my survey measurements. And even when it comes to survey measurements, before we saw we had RSRP, RSSI, RSCP. But now we have all the metrics available that was collected with that Seahawk platform. So we have our PN codes, we have our scrambling codes, we have our PCIs, we have our RSRP, RSRQ, and I could toggle between them, but they're all readily available for me. I didn't have to do any post-processing at all. So since I have all this information for me, the next step would be to really start modeling my venue. And what I did here was I looked at areas where I saw plaster, areas where I saw concrete, and I took actual materials and I replaced these markups with a pen with actual materials. So in order to save time, I already took this step. And as you can see here, I already modeled these walls. And if you want to verify if the wall was modeled properly, you could always visualize it in 3D. So once I verified that all my wall materials were in place, the next step I want to do is I want to make sure that I bring in my CW data so I could do a fine-tune, so I could fine-tune and calibrate my propagation model. So here you can see I have my transmitter back in place. It's already labeled with the right location, right height, and right power, and I have my CW walk. Now, in order to show you the impact of calibration, I just want to show you a prediction before calibrating, and I also want to show you a prediction after calibrating. So I made a prediction based on this transmitter, and I have it right here. Once I enable it, already I can make a visual representation. So already I can see that my prediction already seems pretty accurate. Areas where I see it's blue, it's blue. Areas where I'm seeing it's green, it's green. So my prediction is already pretty close to that CW data that we saw in the field. But since we have that CW, we want to attain an even higher level of accuracy, and that's why we fine-tune and calibrate our propagation algorithm. So that's exactly what I did. I took that CW measurements and I fine-tuned and calibrated my propagation module. So again, we have an option here. We could simply come to calibrate. And since everything was in place, since all my CW measurements were in place, this was really just a one-step process. And just to show you the impact, I'm going to run my prediction again. And now once I run my prediction, already I can see that my colors are a lot more similar to my survey measurements. So I could see areas where it's blue, it's a lot closer to blue. Areas where it's orange and yellowish, it's a lot more closer. And again, at any point in time, you always have the ability of reporting how well your accuracy was in terms of mean error, standard deviation. So that was my next step. I want to have a fine-tuned calibrated propagation module before I go into the next phase of detailed engineering. So I'm going to let Alex speak a little bit more about that detailed engineering phase. So I'm going to pass it back to him.
Thank you, Nazim. So now that we have everything calibrated, we could go on to our next step, right? And there's a couple of things that we already saw benefits to. One of them is being able to capture this information using, mobile and the integration, let's say, through PCTEL, and then using the cloud to set that in directly to the RF engineer that's using design out in the office. So this is a big time saver too. But in the detailed engineering tool, this is also the section where we want to better understand our KPIs. Typically, we have to satisfy some kind of requirement, let's say for RSRP, RSCP, depending on the technology, also for SNIR, RSRQ, for quality. And also, nowadays too, we have to have some kind of a dominance over macro. This step of detailed engineering, it's also going to be the section where we're going to determine what kind of equipment we want to use, right? Based on maybe things like budget or whether we want to future-proof our solution. So we could go ahead and take different scenarios into account for that, because at the end of the day, we want to make sure we design our right system, right? We want to make sure that we're not under-designing, because obviously then we're not hitting our KPIs or our service level agreements that we're trying to achieve. And we also don't want to over-design, because this means that we're going to be using more material and more additional not needed costs for a project, right? So this is something that we could go ahead, and we already saw the benefits of using solutions such as what we showed today. And in our case, what we do is we have the ability of applying our calibrated model, so we assure ourselves that we're going to have a prediction that's very accurate. And in this case, what we did is we looked at two different scenarios to see what kind of our requirements. It's a pretty small office, so we just analyzed one versus two antenna. But you could see when it comes to RSRP requirements, we have the ability of adding a feature to see whether we're reaching the requirement or not. In this case, we have a minimum of -90, and in over 90% of the floor plan, and we're not getting to that requirement with one antenna, whereas with two antennas, we are getting to that. And again, we'll look at other things such as signal quality, in this case, to see whether we're reaching that criteria or not. And obviously, our signal quality is going to determine our throughput. So we have a good understanding whether we're achieving the throughputs that we were meant to be achieving, right, in our design. And very important nowadays too, like I said, we have to have some kind of a dominance. The dominance over macro is going to tell us how clean our signal is, right? Again, today now, not too much about coverage, but you want to have capacity. So you're adding additional systems. You want the throughput, well, you have to have a clean system. We have to make sure that the indoor solution dominates, typically we see from 5 to 10 dB, right? So you have output maps that you could go ahead and use for that. On the previous ones too that I showed, even though they're in 3D format, you can't see it. They were taking walk tests into consideration for that too. And on our tool, we also have the ability to go ahead and generate quick reports, right? Whether you're reaching those requirements for RSRP, for throughput, for SNIR, or that dominance. And in this case, we could see with two antennas, we're going to reach our KPIs. With this same report, you have the ability to go ahead and also view it from a point of multi-building, multi-floor scenario. And if you do need help with setting any of this up, as far as like how to do the output plots or how to set up this compliancy stuff, feel free to reach out to the iBwave team and we could walk through that. But real quick, what we're going to do right now is I'll pass it back to Nazim so he could do a quick demo on this section.
Thank you, Alex. So this is my last portion of the demo, and for this example, like Alex mentioned, the first thing we want to do is understand our client's KPIs and then simulate them and see if we're going to be achieving those KPIs. So that's really the first thing I did, was I first of all looked at the KPIs that are important to the client, and I generated heat maps for them by putting in the criteria that I know I need to achieve. So this was a smaller venue, but the whole process, think of it if for larger venues, the same exact process can be utilized. So for this first step, I did a more of an iterative approach. I started off with one antenna, and I wanted to see what kind of results I'll be achieving with one antenna. So that's what I did. I started to run my KPIs. So the first one I took a look at was my signal strength. And just by running my signal strength already, I'm seeing I'm not achieving that appropriate KPI. I wanted a minimum of 90, a minimum of -70 for at least 90% of my venue. I only achieved it for 80% of the time. And that's already a bad indicator. So if I move on to my SNIR, my signal-to-noise interference ratio, I see even that was not achieved. I had a minimum of 20 and a 20 dB, and I only achieved that 72% of the time when I really wanted 90% of the time. So what this is going to relate to is I'm not going to be able to achieve my actual quality of service. I'm not going to be able to achieve my data throughputs. So again, as you can see, I wasn't able to achieve it. And same goes for my other criteria such as RSRP and RSRQ. I could see that I wasn't really achieving it. So another map that's very important to really visualize is your dominance over macro, because usually this is actually a good map to start off with, because if you're not achieving good dominance, chances are a lot of your other KPIs are going to fail as well. So once I ran this dominance over macro map, I saw that in some areas I was quite dominant, but in other areas I was not very dominant, such as this corner here. So already this was an indicator to me that I need to place additional equipment in this area. And this is the real purpose behind these simulations. We wanted to allow us to better strategize. So just by looking at this map, I already know maybe I should place an antenna here. And just to quickly show you the impact of doing so, I created another design with two antennas. And keep in mind, we always have our survey data. These are all going to be used in our KPI calculations. So I placed a second antenna here. And now when I visualize my KPI, I can see that I'm actually achieving all of them: my signal strength, my signal-to-noise interference ratio, my data rates, my RSRP. They're all being achieved. And even if I come back to dominance, now I can see that I'm actually very dominant throughout my entire venue. And even my criteria, I wanted a minimum of 8 dB dominance for my entire venue, and I actually achieved it 100% of the time. And also what Alex showed us was we had the ability of running a quick report of a compliance report, and this is really meant to help you analyze all your floors for your entire venue, for all your different KPIs. So think of a scenario where you have maybe 10, 15 floors. It's going to be very difficult to go from one plot to another, from one floor to another. So we have this summation page that's going to show us all our different KPIs and if we actually achieved it or not. So this is something we want to present to our end clients. We did all the necessary work and we achieved all your specific requirements. And the last point I want to make, so again, keep in mind, as I mentioned before, think of the file that we started working on as a container. So that container is going to contain all that information that we had starting from my first visit at the venue. So I have all that information available to me in my layers. So if I want to visualize my markup layers, I could quickly turn on my markup layers. I have all my different survey measurements going from baseline to CW, and later on I could bring in validation as well. And finally, when it comes to all our documentation, we could easily pull out a report just to highlight everything that we documented in that venue in a report type format. So again, as I was mentioning before, we don't have to take out our digital camera anymore, take out our pictures, label our pictures, resize them. All that is automated now. And even if you want a higher level of automation, what you can do is you could put your own company backdrop here and even export it into PowerPoint if necessary. Now, this was the last part of my presentation for the live demos. I'm going to send it back to Alex just so we could give a quick summation of what we spoke about today.
Okay, thank you, Nazim. Real quick, key takeaways from today's presentation. We saw how you could go ahead and use tools like iBwave Mobile Note to digitize site survey, your notes, and obviously the RF collection part for savings and deployment time. PCTEL covered the importance of proper RF information gathering, right, with correct methods and hardware such as PCTEL Seahawk Touch. And then we also saw the usefulness of expediting both site survey and RF data directly to iBwave Design to expedite our process when it comes to detailed engineering. So that was what we want to focus on today. Be sure to be on the lookout for information on the next presentation. Part 2 of this is going to be November 11th, and that's going to be sending back, I'll send it back to Amna for some Q&A.
Thank you, everyone. Now we will get to some of the many questions that were asked during the presentation and throughout the GoToWebinar presentation. If you have any additional questions still, you can feel free to type them in the control panel. So the first question that I have is, how do I show cumulative coverage percentage across my whole project, multiple layouts?
Thank you, Amna. So I'll take that question, and if you could make me presenter. And really for this question, I'm going to revert back to the previous report that I just showed you, and this was the compliancy report. So at any point in time, you can come to reports, and you can come to compliancy. And once I run a compliancy report, in this case I only had one floor, but if I had multiple floors, I have the option of visualizing any of my coverage maps along with the criteria that I had, and it's going to tell me for my floor if I achieved that criteria and by how much percent I achieved it. So in this case, if I take a look at my building 1 for my RSRP, I achieved my minimum neg 90 for 99% of the time. Now if I had many floors, I have the option here down below to show all floors and show my cumulative coverage for my entire building. So that's just the different ways. So not only is it going to allow you to see the cumulative coverage, it's going to allow you to really narrow it down floor by floor as well.
Thank you, Nazim. So I have another question. It's about amplification and repetition of external signals versus generation of signal in indoor environments. Which solutions to use?
Yeah, this is Scott. I'll go ahead and take that one. I believe what they're asking here is whether you would want to, where would you want to use a repeater-fed DAS versus a BTS-fed DAS within a building. And with a repeater-fed DAS, if you're looking for just coverage, extending that coverage into the building without increasing capacity, then a repeater-fed DAS will work just fine. But when it comes to offloading capacity from the macro sites, and building capacity into a building that has a large number of people that would be located in that building. It's important that you have a BTS-fed DAS to offload that capacity from the macro sites and build enough capacity into that building to handle the users within that building.
Thank you, Scott. So I have a room for one more question. It's how important is it to do CW testing during site survey for small cells so that you can calibrate propagation models?
I'll take that one as well. You know, CW testing for propagation model tuning is very important, no matter if it's done for a macro site or an in-building site, whether it's for a small cell or a DAS. It's very important to understand the propagation characteristics of the environment that you're designing to, whether it be in building through the different types of media in a building, or if it's external to a building, how it's going to penetrate into that building. So it's very important to do CW testing anytime you're doing design using a propagation model to make sure that those models are tuned properly and your predictions are accurate.
Thank you, Scott. We have room for one last question, and this one is, does the SNR prediction take the macro coverage into account?
Hello. Hi, I'll take that question. So yes, definitely the SNR prediction is going to take that macro coverage into consideration, and that's one of the key points of bringing in that baseline test. So when we did the baseline data and we brought it into our plots, that was really one of the purposes, because we wanted to have good, accurate prediction for not only our SNIR, but also for our data rates. So our SNIR is going to consider the macro signal coming in from that outdoor network.
I'd like to add to that too that today we talked about taking the macro into consideration from a walk test, right? But in design, there's other two ways to take that macro into consideration. So we also integrate with macro planning tools such as Forsk and ATOL and those type of tools to take that in consideration. Or the third way is just to tell the tool, all right, you know, this is assume that it's negative 75 around all the buildings. So those are other ways to take the macro signal into consideration for plots like SNAR.
Thank you, everyone. So those are all the questions we'll be able to answer today. Thank you for attending the webinar, and thank you to the presenters for taking the time. And just before we end, I would like to let you know that if you want to continue the conversation, feel free to join our LinkedIn group, the iBwave InBuilding community. If you're not a member yet, I encourage you to join us. You can also look for the recording and the slide deck from today's presentation in your inbox within the next few days. Once again, thank you for taking the time to join us today, and have a great day. I will now disconnect the call. Thank you.